We all know that our heart has a cardiac muscle that is responsible for contraction to pump blood throughout the different parts of the body. But how exactly does that happen? For today's discussion, we will show you how this contraction involves electrical impulses, which contracts the chambers that pushes the blood to its destination. This system is called the impulse conduction system of the heart. The heart conduction system is a network of nodes, cells, and signals that controls your heartbeat. Each time your heart beats, electrical signals travel through your heart. These signals cause different parts of your heart to expand and contract. The expansion and contraction control blood flow through your heart and body.
What does trigger heart contraction? An inherent and rhythmical electrical activity is the reason for the heart's lifelong beat. The source of this electrical activity is a network of specialized cardiac muscle fibers called autorhythmic fibers. Autorhythmic fibers repeatedly generate action potentials that trigger heart contractions. These relatively rare fibers have two important functions. They act as a pacemaker, setting the rhythm of an electrical excitation that causes the heart to contract. Also, they form the cardiac conduction system. Cardiac conduction system, a network of specialized cardiac muscle fibers that provide a path for each cycle of cardiac excitation to progress through the heart. This system ensures that cardiac chambers become stimulated to contract in a coordinated manner, which makes the heart an effective pump. With the accumulated basic information, let us now proceed in discussing the sequence of process of the heart's impulse conducting system.
First, the cardiac excitation normally begins in the sinoatrial node, or the SA node, located in the right atrial wall just inferior and lateral to the opening of the superior vena cava. The SA node cells do not have a stable resting potential. Rather, they repeatedly depolarize to threshold spontaneously. The spontaneous depolarization is a pacemaker potential. When the pacemaker potential reaches a threshold, it triggers an action potential. Each action potential from the SA node propagates throughout both atria via gap junctions in the intercalated discs of atrial muscle fibers. Following the action potential, the two atria contract at the same time.
By conducting along atrial muscle fibers, the action potential reaches the atrioventricular AV node located in the interatrial septum, just anterior to the opening of the coronary sinus. At the AV node, the action potential slows considerably as a result of various differences in cell structure in the AV node. This delay provides time for the atria to empty their blood into the ventricles.
Third process, from the AV node, the action potential enters the atrioventricular bundle, also known as the bundle of His. This bundle is the only site where action potentials can conduct from the atria to the ventricles.
After propagating through the AV bundle, the action potential enters both the right and left bundle branches. The bundle branches extend through the interventricular septum towards the apex of the heart.
Finally, the large diameter Purkinje fibers rapidly conduct the action potential beginning at the apex of the heart upward to the remainder of the ventricular myocardium. Then the ventricles contract, pushing the blood upwards towards the semilunar valves, pulmonary valve that delivers blood to the lungs, and the aortic valve which delivers blood to the rest of the body.
As action potentials propagate through the heart, they generate electrical currents that can be detected at the surface of the body. This composite record of action potentials produced by all of the heart muscle fibers during each heartbeat is called an electrocardiogram, or known as ECG or EKG. And the instrument used to record is an electrocardiograph. The correlation of ECG waves with atrial and ventricular systole. The first wave, P wave, represents atrial contraction. Second wave, QRS complex, represents rapid ventricular contraction. Third wave, T wave, indicates ventricular repolarization and occurs just as the ventricles are starting to relax.
A video will be provided for you guys to understand the process along with its correlation with the electrocardiogram more clearly.
Your heart is a muscle that works continuously, much like a pump. Each beat of your heart is set in motion by an electrical signal from within your heart muscle. The electrical activity is recorded by an electrocardiogram, known as an EKG or ECG. Each beat of your heart begins with an electrical signal from the sinoatrial node, also known as the SA node. The SA node is located in your heart's right atrium. When your heart's right atrium is full with blood, the electrical signal spreads across the cells of your heart's right and left atria. This signal causes the atria to contract, or squeeze. This pumps blood through the open valves from the atria into both ventricles. The P wave on the EKG marks the contraction of your heart's atria. The signal arrives at the atrioventricular or AV node near the ventricles. Here it is slowed for an instant to allow your heart's right and left ventricles to fill with blood. On an EKG, this interval is represented by the start of the line segment between the P and Q wave. The signal is released and moves next to the bundle of His located in your heart's ventricles. From the bundle of His, the signal fibers divide into left and right bundle branches which run through your heart septum. On the EKG, this is represented by the Q wave. The signal leaves the left and right bundle branches through the Purkinje fibers that connect directly to the cells in the walls of your heart's ventricles. The signal spreads quickly across your heart's ventricles. As the signal spreads across the cells of the ventricle walls, both ventricles contract, but not at exactly the same moment. The left ventricle of your heart contracts an instant before the right ventricle. On an EKG, the R wave marks the contraction of your heart's left ventricle. The S wave marks the contraction of your heart's right ventricle. The contraction of your heart's right ventricle pushes blood through the pulmonary valve to your lungs. The contraction of your heart's left ventricle pushes blood through the aortic valve to the rest of your body. As the signal passes, the walls of your heart's ventricles relax and await the next signal. On the EKG, the T wave marks the point at which your heart's ventricles are relaxing. This process continues over and over.
That would be all for the impulse conducting system of the heart. This is Zaki Ortega.
This is Juliana Francine Marfil.
Thanking y'all for listening, and I hope you learned something.